Welcome. So, in this video, I'm gonna teach you in two parts how to basically build a long-distance CB station. It's gonna be a base station placed at your home. However, it is very important, and I have three disclaimers to actually make. This is a long-range distance and communication. This will require a couple of tools that, if you are a starter on CB radio, you shouldn't just jump into it right now. Please get your CB radio first, a power supply and an antenna, and just establish contacts locally first. This is important because DXing on CB, DXing is the slang that we use for long distance, requires that you are educated on CB rules and when to let people talk. The second disclaimer that I would like to make is that this video is completely unscripted. You're gonna hear me ramble a lot, mix up words. There's gonna be a lot of stuff like that. The only things that I have near me that are somehow close to what could be probably a script part are a calculator and a pen with some paper. I also have a glass and a bottle of Jack Daniels because, well, yeah, that's gonna be one of those videos. Last disclaimer. I'm gonna talk about linear amplifiers. They are not very well seen in the CB community. Again, if you are a newbie, you will know this, that you shouldn't use linear amplifiers if you are establishing local contacts, because you will just destroy everyone's signal. If you, however, are establishing a long distance contact with a channel that just appears to be having foreigners on it, you can use the linear amplifier. These are the rules that you need to learn. You can use all the power that you want as long as you respect the rules. Another thing, linear amplifiers in some places are a gray area, in other places are completely illegal. So please try knowing the law that applies to your country. Okay? So we're going to divide this video into parts. This part that I'm even filming with the fancy microphone is going to be the lesson, the theory lesson, plus picking up a good antenna, or making your own antenna, or, you know, there are many alternatives, there are many things you can do about the antenna. But the antenna is the key component for any CB station. Also, this CB station is not a mobile one, okay? While some people can do this on mobile stations, it's not really a thing you can do easily. And in the second part, I'm gonna build the station itself, picking up the radio, the linear amplifier, and the power supply, and assembling everything together and explaining what each part does. All this without trying to bust the bank account. I'm gonna reuse a lot of parts that I had around here. I probably am gonna buy some new parts that I don't have. Well, we will see how that goes. So, to start our lesson, and it's important that we actually start by explaining how waves actually propagate. So, in this first picture, this is basically all the types of HF waves. We are working with the 26 to 30 megahertz, so 10, 11 meters, which essentially is the green dotted line. This wave is reflected in the ionosphere, specifically in the F region. However, during the day, when the E region is available, more on that later, it can be reflected in the E region, which is not desirable. See, each time there's a reflection of a wave, some power is lost, even here on the ground. Now, if we look at this, wave that actually has a E region, it is actually reflecting 3 times. We could do this just like we could reach the same distance with just 2 times if it wasn't for this E region. Which brings me to the next part of the ionosphere. How to avoid the E region? Well, the E region can be avoided, and well, the D is not really in this equation. I'll talk later about the F1 and F2 regions, but the E region can be avoided by just doing this at night. You will obtain better results at night, because the ionosphere is just not as divided as it is when it is exposed to sunlight. Okay. Now back to the okay. Where's the diagram? Yeah. Well. Okay. Now, yeah, it's really this one. So the F1 and F2. Sometimes you will reflect out of F1, and other times you will reflect out of F2. It's really random, and sometimes you will reflect out of E. So during the day, it's a bit of an unpredictable behavior. The other thing, back to this picture, is that you will establish better contacts if you are over the sea and not over, mountains or stuff that will disperse your wave in every direction except the correct one. It's just so over the sea. So keep this in mind. Over the sea and at night are the best conditions. Now, some FUDs of the CB community, they'll say, "Oh, you don't need a linear amplifier. You need the right conditions." Yeah, well, under the right conditions, you can do everything. But the reality is that we don't always have the right conditions, and this F layer at night sometimes doesn't work exactly the way that we want it to work. This is the ideal behavior, but sometimes just a matter of temperatures, it can behave differently. Yes, you can reach the United States. If you are here in Western Europe, you can reach the United States at night on the limit of 10 watts of single sideband of stock CB radio. Under the specific conditions, but under the specific conditions, a person in a wheelchair could win me against the sprint in 100 meters obstacles or something, under the right conditions. For example, the race is done downhill and some mobster puts a lot of money in the wheelchair guy and beats the shit out of my legs. So yeah, in that case, the wheelchair person will win. That's the right conditions for the wheelchair person to win. That's also the right conditions for, transmitting on the stock CB radio wattage. But we don't always have a right to, and we always don't have the right conditions for that. Now, with that said, that's why I'm going to include a bit further in part 2 the use of linear amplifiers. You have also seen me use a linear amplifier to establish contacts during the day.
Attento Angelo, ci sei? Mi ascolti? Hello Angelo, good morning. This is 31 Foxtrot Alpha 250 3 Tango from Portugal. Can you read me? How is my signal?
Okay, good morning, my friends of Portogallo. Good morning, this is the station Viluccio from Roma. You listen me?
Yes, sir. I listen to you very well.
Okay, thank you.
This one is a way weaker linear amplifier. It's a 35 watt KL60. Some people say that it makes 60 watts in single sideband, but not it doesn't. It's 35 watts. And I established the contact with Italy from Lisbon, Portugal, roughly. I'm not going to reveal my location, but trust me, it's around that. I'm actually in an advantage because by being located in this general area, I can contact most of Europe if I have enough power, but I can also contact the United States. I established contacts with Oklahoma, Kentucky, South Carolina, most of these states on the East Coast. I was able to actually establish contacts. Never established one in like New York or Canada or people like that, but I know that some amateurs near me have done that because I have access to some registries of my town's CB club, and we like to brag when we do DXs with other people. On that note, it's important to pick your antenna. So I'm gonna show you a couple of antenna harmonics. Ideally, you would pick, so CB is 27 megahertz, which makes it a 11 meter wavelength. Ideally, you would pick a full wavelength, but nobody's gonna just have an 11 meter antenna just hanging around. If this was like, VHF, which is like 2 meters, or UHF, which is 70 centimeters, it's way more doable. But 10 meters, 11 meters, Jesus, it's not that much doable. So the most common antenna designs are 3/4 of wave, 5/8 of wave, half a wave, and a fourth of wave. Now, the smaller the antenna, the less the power the less the gain you will have, and it's something that is actually it's an exponential formula. 3/4 of wave is actually, so let's start by the smaller one actually, which is 1/4 of wave. As you can see, we just have basically two big points here. Half a wave, we have two big points too, but they go a little further. They have a little bit more gain. This is a gain graph, by the way. They have a little bit more gain than the 1/4 of wave. The 3/4 of wave, in this point it has lower gain, but in here it has about the same gain as half a wave. However, as you can see, half a wave just has two big points, while 3/4 of wave has two big points and two smaller points. This actually like mirrors down, so in reality half a wave will just have two big points really, and 3/4 of wave will have two smaller points and four big points, but let's not enter into that. So 3/4 of wave actually performs way better than half a wave, as expected. And 5/8 of a wave, it has the most gain on the longest compared to 3/4 of wave. On the longest side, it has way more gain than 3/4 of wave. But unlike 3/4 of wave, on the smaller signs, it will actually have 3/4 of wave will actually have more. And if this was a full wave, basically all the sides would be the same size, and all would be like 0 decibels, since this is a negative scale. They all would be at 0 decibels. So now we need to pick. Now we can see that from this analysis that it's either 3/4 of wave or 5/8 of wave. Like it's the best because they have the most capture. They actually have the most capture capacity. Now I must also explain that while 3/4 of wave has less gain than 5/8 of wave, the distance from ear to ear is bigger than the distance from ear to the other side of ear. What does this mean? This means that 5/8 will have higher gain. It will receive signals from far away, but 3/4 of wave will have higher quality, higher quality of sound. Okay. Same with 1/4 of wave. It will receive signs from less distance than half a wave, but it will have higher quality. Okay. So basically, the bigger the bump, the higher the quality. Now, considering this, I personally chose 5/8 of wave. 5/8 of wave is an antenna that is shorter than 3/4 of wave, and it doesn't offer, like in my case, since I'm going for longer ranges, in my case it made sense. 3/4 of wave did not offer much more of the didn't offer much more of an advantage for me to actually choose 3/4 of wave. And now that brings to the second part of the theory, which is building the antenna. Now, building the antenna was not easy. So I calculated this by actually multiplying 10 instead of 11 because I'm a bit of an idiot, and it gave me 6. So multiply 10 by 5/8 to actually get the length of the antenna, which gave me 6 meters and 25 centimeters. The antenna itself, the antenna that I have, only part of it, like the first meter, actually came from a real shortwave antenna of some kind, because the rest had to be improvised with shower curtain rods and a bunch of aluminum parts that I found. Yeah, but as you have seen before, it actually is able to DX, to listen people from Italy, and to listen people from the US. I don't have a video of that, but yeah, to listen and to talk to people in Italy, it's actually good. But yes, this antenna is 5/8 of a wave, but it's for the 10 meters. I made a mistake here. So because this is so, in that case, you would need to actually find the right length for 11 meters. So you multiply 5/8 times 11 meters, which will give you 6.87 centimeters and a half. Okay. And yes, 6.875. That's the result. So 6 meters, 87 centimeters, and 5 millimeters. With this in mind, and so it's such a specific length that I would probably build a 7-meter antenna. And honestly, a DXer that lives relatively close to me, and by relatively I mean like 60 kilometers, told me over CB that he actually has an improvised antenna made of 2 fishing rods, which yielded 7 meters. And he's able to get contacts with Canada and stuff like that. So, I mean, great. I improvised with shower curtain rods, improvised with fishing rods. We all have our ways. Now, after building the antenna, it was time to put it in place, which is easier said than done. So as you can see some details here. So this part here is where the real antenna ends and the shower curtain starts. And I drilled a hole to screw in to have a lock screw, but the lock screw did not have a hole on the other side, so it just locked against the threads of the antenna, so part of the screw is out. This happens on all the screws of the antenna upwards. It's like divided in 4 sections or so, or 5 sections. And that's a bit of a problem. Like, there's a bit of signal leakage over there. It's not really that much, but there's a little bit. Okay. But yes, the antenna is in place and it's built. I'm showing pictures because right now it's night, it's dark, and I don't really feel like going outside to take pictures, especially because it's cold. Now, the antenna, well, sorry for the grainy picture, like it is, you know, like there's something radioactive or something. I was actually chewing on a Cobalt 60 rod at the time, so the camera didn't like that. I don't really know why. Now the antenna looks a little bit bent, and that's because it is. This was after a storm, and to have an idea, I have here a small UHF antenna for ham radio that is actually turned 90 degrees to where it should be. It should be pointed in. It should be completely. It should be like this and not like this. But well, that's the way it is, right? Oh, this is antenna 4. Okay, where's antenna 3? Yeah. So here's an even more grainy picture that shows it. This antenna should be pointing that way and not this way. But yes, well, that is what I get. And this is basically my antenna design chose, the 5/8. You could pick 3/4, it all depends to you. And now let's talk equipment, and let's talk the system itself. Having the theory on how the troposphere and the antenna works, and having an antenna chosen, let's talk about the system. So, the system works something like this. You have a radio. The radio is also connected to the battery. I don't even know why didn't I connect the radio to the battery. It's probably because I'm an idiot. You have a radio. It's connected to a linear amplifier. And the linear amplifier is connected to the antenna. Sounds simple enough, right? You need to be picky with your parts. I would recommend a PSU. Since this is a base station, we are going to use a PSU. Now it says 13.6 volts. So we need to keep in mind this value. In fact, I'm actually gonna take notes for part 2 of this video, for the second part. So the PSU needs to be at 13.6 volts. There we go. Should not forget that. Now, your radio, you should have a good radio. Shouldn't have just a cheap radio that is for AM, FM, or anything like that, okay? You should have a radio that is also capable of SSB. They are gonna come a bit more expensive, maybe you can find a used Cobra GTL for a cheap price. Maybe you can scavenge a Cobra GTL clone like I did. I'll explain on part 2 all the scavenged parts that I have and all the parts that I bought new. The parts that I bought new, spoiler alert, I had a PSU, but the PSU would not gonna cut it, so I had to buy a new one. And obviously the linear amplifier, because the linear amplifier is a little bit little, so yes. The antenna, well, I built the antenna, as I explained, and the radio, well, it's a story that I will tell you in the next part of this video. For now, thank you for watching.